Hi, I'm Michael Pfeiffer, Principal Consultant and Trainer at Industrial Metallurgists. I just want to take a few minutes to explain about the metals and materials engineering support that we offer to our clients. So we offer a variety of engineering services to clients, and these are clients involved with product design and manufacturing. So we help with design. This is reviewing material specifications for component drawings and making sure that the material specifications are thorough. Materials and process selection, so metals selection or alloy selection and coating selection for components, helping to develop material and component reliability tests. This would be doing testing prior to doing product level testing in order to gain information to help understand the optimum component design requirement or designs from the perspective of the component form and the metals being used in the component and how the component is fabricated. And finally, helping with reverse engineering of competitors' products. We also help with supplier evaluation to help companies make sure that they are selecting suppliers who are capable of consistently providing metals and components that will meet requirements. We help with manufacturing development and quality improvement. Also help with materials identification and characterization. This includes metals, coatings, plastics, and other materials. And finally, we help with failure analysis. This can be with component failures in products and also quality problems that happen with either manufacturing quality problems or supplier quality problems. So we provide a variety of engineering services to help our clients um, deal with metal decisions and problems in their products. So we handle all aspects of product design and manufacturing from start to finish. So and I want to talk about how we work with clients. So we have a few different arrangements for working with clients. The first is a project-based arrangement. This is when a client has a very specific project and they need help. Typically, we will quote a flat rate for up to 6 hours of engineering time. And then if any additional engineering time is required, we will provide a quote for that work. And then we also work with companies on a retainer basis. Companies pay a certain amount for a certain number of hours, let's say 8 hours of our time, and then they can call with questions or problems and use up the time as needed. This enables companies to be able to have access to a metallurgist without having when they don't have one on staff full time, and without having to go and go through a purchase order every time that someone needs help. And it gives people the independence and freedom to be able to ask for help when they need it. That is, the engineers, whether it's design engineers, quality engineers, or manufacturing engineers. And finally, we offer a 1 hour consultation. You can purchase 1 hour of time online, and then we'll meet to talk about the problem or a question or a decision you're facing. And this 1 hour is often very helpful for giving people some clarity about their next steps to take or the options that are available to them from a metals engineering perspective. Regardless of the arrangements, we work as part of our client's engineering team. We don't just take, get information from you and then go off and do work and then just hand off a report. Our goal is to work with you to help understand the problem or the decision or the question, get background information and help make sure that the decision or the question that you're trying to answer, the problem you're trying to solve is really the problem, or the question or decision you really think it is, and work with your engineers to identify the data and information that's needed and then help get the data and information and then work with them to understand the data and information and then make decisions and answer their questions based on that. And we, of course, will work with people, communicate with email, phone, and we like to use Zoom, but we'll also use your virtual meeting software if you have something else that you prefer. And the process is the same regardless of whether it's a project, a retainer, or the 1 hour consultation. We're going to first, the client emails or calls with a question, problem, or a project. We'll meet to review the project and discuss the background. If it's a retainer type question and it's a question that the client can ask via email, then we can also run with that. But quite often for projects and for problems, it's important to me to review the project and discuss the background. Then we'll identify the information and data that's needed and the steps to do the work. Then we'll do our part to get the information and data. I will work with labs as your metallurgist to get any analyses done. You don't have to worry about taking care of that. And then I'll review the information, the data, and the findings with the engineering team, and then, if necessary, provide a written report. And we work with a variety of different labs. They have lots of different capabilities to be able to get the information that's needed for any particular project, question, or decision. And just a few examples. One is a client had a question about a hydrogen bakeout, whether it was necessary to specify that on the components that were going to be on steel components that were going to be plated. And we spent about an hour getting the information from them and providing information that helped them understand that they did not need to call for hydrogen bakeout. Another example is for valve part wear. This has helped to identify materials that can withstand exposure to wear. They originally were thinking about tungsten carbide, which is expensive, and there were some other issues with that. Nitriding is a very common, readily available technique used with steels. This enables a strong core with a high surface hardness, and materials and processes readily available. So we identified nitriding as a possible source, and the final source ended up being a 4140, actually carbonitrided steel, and 8620 carbonitrided. So carbonitriding provides high hardness and high strength at the surface for wear resistance. And the final example is mixing blades that were bending and fracturing during use. These are mixing blades used in an industrial dryer. The blades were bending and breaking. The blades consisted of a stainless steel paddle or sheet plate that was welded to a shaft. And as we did a failure analysis, this shows a camera photo of the fracture surface. This is a scanning electron microscope image of the fracture surface. And so the step is to collect the background information, the materials being used, the process that was being used in when the components were failing, the history of the failures. Also, we collected samples, and then we had the analysis performed and used visual and stereo zoom. Used a variety of analysis techniques to get the information needed to understand what was happening. And it turned out that the blades were failing due to high cycle fatigue. So the root cause, I did some further investigation and found that the variations in the motor electrical supply voltage can cause shaft acceleration and deceleration. It was determined that there were some very large voltage swings in the electricity provided to the equipment, the drying equipment. So one of the fixes was to clean up the electrical power so that there weren't the large swings in voltage and the large accelerations and decelerations that were causing the stresses that were resulting in fatigue, crack forming, and growing in the metal. So that's an example of a problem, and that was a problem and a project. So hopefully this will help you understand the services that we can provide to you. If you don't have a metallurgist on staff, we can provide all the metallurgy help that you need in order to help with decisions, questions, and problems. If you have any questions, feel free to email or to call. My email address and phone number are here. Thanks for watching, and good luck with your metals. Bye.